Hello and welcome to IoT Boot Camp organized by Mituf Software and Embarcadero. My name is Bojan Mituf, the president of Mituf Software, and today I will show you how to get started with Arduino programming. First, what is Arduino? Arduinos are microcontroller boards designed by the open source Arduino community. When they designed and introduced the boards, they also created a development IDE called the Arduino IDE, and they created a standard uniform software API for working with those boards. Following the success of the Arduino boards and the IDE, many other controllers implemented the same Arduino API and made it possible to be programmed and supported by the Arduino IDE. Here are some examples of Arduino boards. They can come in different sizes, shapes, capabilities, and some of them are even designed as ready-to-use robots. There are many different Arduino clones. Here are some examples. They have a variety of enhanced capabilities such as GPS, GSM, Wi-Fi, Bluetooth, and other forms of connectivity. Others are intended for industrial control. There are boards which are extremely small, have audio processing capabilities like this Teensy, and some of them come with small factor and built-in Wi-Fi capabilities like this Node MCU Mini manufactured by Maker Fabs, which is included in the Maker Fabs kit for the IoT Boot Camp. Typically, to program the boards, you can use the Arduino IDE. It's a very simple IDE, not much more than a glorified Notepad. It very much allows you just to edit a file and once done, compile and upload it to the Arduino board. The code is single-threaded and typically is written in two sections, setup and loop. Controlling multiple sensors in the loop section can be quite challenging, and anything more complex than just blinking LED usually requires considerable effort. To overcome these problems, I have created the Visuino IDE. The Visuino IDE allows you to graphically program Arduino-compatible boards once when the design is finished. By clicking a button, Visuino will generate the Arduino code and then open the Arduino IDE, and then from here, by clicking another button, you can upload the code to a variety of Arduino and Arduino compatible boards. The IoT kit that I will use for this session includes Arduino Nano, like the one shown on the picture. The Arduino boards typically have number of inputs and outputs. The typical inputs are digital and analog. The outputs can be digital, on-off, digital with pulse width modulation, or analog. The Nano is a simple board and has only digital and digital pulse width modulation output pins. The same pin can have multiple capabilities and can be programmed as input or output. In addition, there are a variety of communication pins such as serial, SPI, and I2C communication. Here are only shown the pins with the serial communication, but in this area here are the SPI pins, and also A4 and A5 serve as I2C pins. We can connect a variety of sensors to Arduino. There are many different types. The typical ones are digital, analog sensors, digital sensors with proprietary communication protocol, serial protocol sensors, SPI, and I2C. There are thousands of different sensors that can be connected to Arduino. Here are some types that are included in the IoT kit from MakerFabs. They are button, joystick, photoresistor, rotary encoder, keypad, infrared receiver, ultrasonic sensor, DHT11 temperature and humidity sensor, and MPU 6050 accelerometer and gyroscope sensor. We will use them to demonstrate the different ways of working with digital, analog, proprietary digital protocol, or I2C communication sensors. Now let's take a look at the Visuino IDE. In the center is the design area. There always is at least one component which represents the Arduino board. If we click on this Tools button here, or just double click on the board, we'll see a dialog listing all currently supported boards. Since we will program Arduino Nano, we'll select Nano as board. When you select a different board, Visuino will automatically populate the different pins corresponding to the selected board. On the left, we have Object Inspector, where we can edit the different properties of the board or other selected component. On the right is our toolbar. Here are our components organized in categories and subcategories. We can select components from here and drop them in the design area. In the left top corner is our navigation panel, which allows us to quickly and easily navigate over big designs. At the bottom is the serial terminal and the scope. And if we use packet communication, also we'll have a tab with visual instrumentation for the different channels. The Arduino Nano has built-in LED connected to pin 13. This is also shown on the Arduino component in Visuino. One of the simplest projects that we can create is to make this LED to pulse on and off once a second. To make it pulse this way, we can add a pulse generator. We can use the filter box to filter through the components. Select a pulse generator and drop it at front of pin 13. Connect it, and by clicking on this button, we can generate the Arduino code and open the Arduino IDE. Here, we can select a board, in our case Arduino Nano, a COM port where the board is connected, and then we can click on this button to compile and upload the code to the Arduino board. The code is uploading, and you can see that the LED is now flashing once a second. We can use the Object Inspector to specify a different frequency. As example, 5 times a second. Again, we can click on this button to generate the Arduino code and open the Arduino IDE. And click on this button to compile and upload the code. And now it is uploading to the Nano. And you can see that the LED is now flashing 5 times a second. For this project, we'll connect a button sensor module to digital pin 2 of Arduino Nano. To connect the button, we'll use red wire to connect to VCC power, black wire to connect to ground, and blue wire to connect to the remaining signal pin. On the Arduino side, we'll connect the black wire to one of the ground pins right here, the red wire to 5 volts, and the blue wire to digital pin 2 of the Arduino Nano. Since our button is connected to digital pin 2, we can simply connect this digital pin 2 to pin 13. We can leave the pulse generator, it will have no effect. Generate the Arduino code and open the Arduino IDE. Compile and upload the code. If I press the button, the LED will turn on, and if I release it, it will turn off. This means that we can read the position of the button and send that value to the LED. If we want, we can invert the value from the button by using Boolean inverter. Connect the button or digital pin 2 to the inverter and the output of the inverter to digital pin 13. To increase the design area, we can also close the serial terminal. Generate the code, compile and upload. Now, by default, the LED is on, and if I click the button, it will turn off, inverting the signal from the button. We can also use the button to enable or disable the pulse generator for the LED. For this, we can add pin to the enabled property of the pulse generator by clicking on this pin button at front of the property, selecting Boolean sync pin, connecting the digital pin 2 to the enabled of the pulse generator, connecting the output of the pulse generator to digital pin 13, and removing the inverter. Generate the code, compile and upload. The LED initially is off. If we press the button, the LED will start blinking 5 times a second as we last programmed it with the pulse generator, and if I release the button, the LED will stop pulsing in whatever state it was at that moment. For the next project, I will use the photoresistor module from my IoT kit from Maker Fabs. This module contains analog photoresistor and a digital comparer. The module is capable of outputting both analog and digital signal, and it can be connected to an analog or digital pin on the Arduino. It also has 2 pins to provide power and ground. We'll start by connecting it as a digital sensor the same way as our button was connected to digital pin 2. This potentiometer here can be used to control the trigger level for the comparer, this small chip, on the module. Here is how I have connected the module to the Arduino Nano. I disconnected the button from the previous project, connected the red wire or power to the first pin, which is the VCC pin, the black wire ground to the ground pin, and the blue wire to the digital pin of the module. The Arduino is still connected as in the previous project with the blue pin going to digital pin 2 and the red to 5 volts and black to ground. We will use the same project as we did for the button. Whenever the photoresistor is exposed to light, the signal is low or zero and the LED on pin 13 will not flash. If I cover the photoresistor or point it to darkness, the LED will start blinking, indicating that we don't have enough light. Whenever the photoresistor is exposed to light, the LED will stop blinking in whatever state it was in that moment. If we want, we can also monitor the digital pin 2 on the serial port. We'll start with new project. Select the board type. Connect the output pin of digital channel 2 to the in pin of serial port 0. Generate the code and open the Arduino IDE. Compile and upload the code. The code is uploaded and now we can test the project. We can connect to the Arduino Nano with the serial terminal in Visuino. First, we need to select COM port, speed, leave the rest of the settings unchanged, and click Connect. We'll connect to the Nano and we'll start seeing the changes between true and false of the photoresistor when the lighting changes. And we can clear the serial terminal after we are done. The photoresistor module has both digital and analog pins. We can change the connection to the analog pin by moving the wire, and on the Nano side we can disconnect from digital pin 2 and connect to analog pin 0. Now we can read analog level from the photoresistor. Again, we'll start with new project. Select the board. Connect the out pin from analog channel 0 to the serial port and generate the Arduino code. Compile and upload the code. The code is uploaded, and again we can connect with the serial terminal. You will immediately see the values from the photoresistor. If we cover it and make it darker, the values will increase, and the more light we get, the lower the values will become. We can also monitor this from the scope. you can see that we can read the analog values and monitor them on the scope and in the terminal. For this project, I will connect the infrared receiver module from the IoT kit to Arduino Nano. I will connect black wire to the ground pin on the module, red wire to VCC to provide power, blue wire to the data pin. On the Arduino Nano, I will connect the black wire to one of the ground pins, red wire to 5 volts, and the blue wire to digital pin 2. In this project, I will also use the infrared remote controller from the IoT kit. Make sure that the controller has battery. Start with new Visuino project, select board type, add infrared receiver component, connect the output pin of the digital channel 2 of the Arduino component to the sensor input pin of the infrared receiver module, connect the output pin of the infrared receiver module to the input pin of serial channel 0 of the Arduino component. Generate the Arduino code and open the Arduino IDE. Compile and upload the code. The code is uploaded. If we connect with serial terminal, we will start receiving the codes of the buttons that are pressed on the remote control on the serial terminal. As example, I will press the OK button last so we can receive the code. And we can disconnect from the serial terminal. Now that we know the code for the OK button, we can use it in our Visuino project. Click on the Tools button of the infrared receiver component. The remote controller is NEC. There is a way to discover that, but we will not cover it in this short tutorial. I will add the code NEC command element, and I will copy and paste the value that we have received for the OK button. Then close the Elements dialog. I can disconnect from the serial terminal since we don't need it anymore. And I will connect the output pin of that command to pin 13, where is the LED on the Nano. Generate the code and open the Arduino IDE. Compile and upload the code. Now I can use the remote to turn on and off the LED. When I press the button, the LED will turn on, and when I release it, it will turn off. Now we have a remote control with our Arduino Nano. For this project, I will connect the accelerometer and gyroscope module from the kit to the Arduino Nano. The module is I2C. I will connect red wire to VCC to power it, black wire to ground, yellow wire to SCL clock for the I2C, green wire to SDA data for I2C. You can see the wires also from the bottom. On the Arduino side, I will connect the black wire to one of the ground pins, the red wire to 5 volts, the yellow wire to A5, which is also I2C clock, and the green wire to A4, which is I2C data. We will start with new Visuino project. Select board type, add accelerometer module. In my case, MPU 6050, which is included in the kit, and drop it in the design area. The module sends both acceleration and gyroscope rotation data, and it also has temperature sensor. We can send the data in the form of packet or structure through the serial port, but in this project I will demonstrate you how you can print formatted data in the serial terminal. We'll add formatted text, add 6 analog channels for the accelerometer and the gyroscope, and close the elements editor. We will connect the output of the formatted text to the input of the serial channel. Connect the output pins of the accelerometer to the first 3 analog channels, and the output pins of the gyroscope to the last 3 channels. Connect the output pin of the accelerometer gyroscope module to the in pin of the I2C channel of the Arduino. We can run the project as it is, and the formatted text will use the names of the channels to indicate the different data. However, we can customize the printout. To do that, I will enter the following text: AX for accelerometer X data, AY for the accelerometer Y, AZ for the accelerometer Z, GX for the gyroscope X, and so on and so forth. By using %, 0%, 1%, 2, 3, 4, and 5, I can specify which analog element will be placed in this particular location in the text. If I want to display % symbol, I simply can add 2% symbols one after another, and it will add % in the text. The project is ready, and now I can generate the Arduino code and open the Arduino IDE. Compile and upload the project. The code is uploaded. Now we can connect to the module with serial terminal. And you will see the data arriving from the module. If I rotate the module, you will see the data from the sensor changing and being printed in the serial terminal. With Arduino, we can control different types of modules. They can be simple digital, such as relay or LED, digital using multiple pins, such as stepper motor or multicolor LED, digital using proprietary communication, as example an infrared transmitter, analog, such as speaker, analog with pulse width modulation, including as example a servo, I2C, and SPI. There are thousands of different modules that can be controlled with Arduino. In the Make and Fabs kit are included multicolor LED, relay, servo, stepper motor, and infrared transmitter. For the next project, we'll connect a relay module to the Arduino Nano. The relay module is connected with red wire on VCC power, black wire for ground, and blue wire to control the relay as a control signal. On the Arduino Nano, we'll connect again the black wire to ground, red wire to 5 volts, and the blue wire to digital pin 2 of Arduino Nano. We'll start with new project, select board type, add a pulse generator, and connect the pulse generator to digital pin 2. We'll change the frequency of the pulse generator to 0.5 or half Hertz, 1 pulse every 2 seconds. Click on this button to generate the Arduino code and open the Arduino IDE. Compile and upload the code to the board. The code is uploading. And now you can see that the relay is turning on and off every second. In this project, we'll connect servo to our Arduino Nano and we'll control it with sine wave generator. The servo has 3 wires. The brown wire is ground, the red wire is power, and the orange wire is signal, control signal. The wires end with female connector, and we'll use male to female jumper wires to connect the servo to the Arduino Nano. We'll connect black wire to the brown wire on the servo, red wire to the red wire, and orange wire to the orange wire. On the Arduino Nano, we'll connect the black to ground, the red to 5 volts, and the orange to digital pin 2. We'll start with new project. Select board type, type sine in the search box for the component toolbar. Select sine analog generator and drop it. This will generate the signal for our servo. Next, we need to add components to control the servo. Type servo. In the search box, select servo component and drop it on the phone. Connect the servo component to digital pin 2, the sine generator to the servo component, and we can lower the frequency of the sine generator to 0.5. And we can generate the code and open the Arduino IDE. Compile and upload the code. The code is uploading, and you can see the servo moving back and forth following the sine wave. In this project, we will control a servo with a joystick with the help of Arduino Nano. The servo is connected with 3 wires. They are male to female wires. The brown wire from the servo is connected to a black wire. This is ground. The red wire is power and is connected with red wire. And the orange wire from the servo is connected to orange jumper wire. On the other end, the orange wire is the control signal and is connected to digital pin 2 on the Nano. The black wire is connected to ground and the red wire is connected to 5 volts. To power the joystick, we can use the analog reference power from the Arduino Nano. It is this pin right here, and it is designed to provide reference power to analog sensors such as this joystick. We will use only one direction of the joystick, the X direction, so we need to connect ground with black wire, 5 volts with red wire, and the VRX, the x-axis signal of the joystick, with blue wire. The blue wire will be connected to analog pin 0, the red wire to analog reference power, and the black wire to another ground on the Arduino Nano. And here is the entire setup. To program, we'll start with new project. Select board type. In the search box of the toolbar, type servo. Select the component and drop it in the design area. Connect the output of the servo to digital pin 2 and the input pin of the servo to the output pin of analog channel 0. Generate the code, compile and upload. The code is uploading, and now we can test the project. You can see that I can use the joystick to control the position of the servo. And if I release the joystick, the servo will go to neutral position. In this project, we will connect a stepper motor to the Arduino Nano. The stepper motor arrives with stepper motor driver board and we need to connect the motor to the driver board with this connector. The driver board has two connectors. One is to provide power, plus and minus, and the other is to control the steps on the stepper motor. For the power, we'll connect black wire to minus or ground and red wire to positive. We will connect another 4 wires, orange, yellow, green and blue, to the 1, 2, 3 and 4 phases of the motor. We'll connect the other end at the orange, yellow, green and blue wires to digital pins 2, 3, 4 and 5, with orange being connected to 2 and the other end of orange connected to phase 1. The black ground wire will be connected to one of the ground pins on Arduino Nano, and the red wire to 5 volts on Nano. We'll start with new Visuino project. Select board. In the component toolbar search box, type stepper. Select 4-wire stepper motor component and drop it in the design area. Click on the block with the 4 pins on it and move the mouse to the digital input pin of digital channel 2. Then click. This will connect all the wires at once. The component has 2 properties that can control the direction and the speed of the stepper. We can upload the code as it is and the stepper will start immediately rotating. However, it will be more interesting if the stepper reverses direction every second. For this, we can add a pulse generator. For the reversed property of the stepper, we can add sync pin and then connect the pulse generator to this pin. And we can reduce the frequency of the pulse generator to 0.5, so every second the direction will change. Generate the Arduino code and open the Arduino IDE. Compile and upload the code. The code is uploading. And you can see that the motor changes direction once a second. I have added a large paper clip to show you easier the rotation of the motor. In this project, we will use a joystick to control a stepper motor with the help of our Arduino Nano. The stepper motor comes with driver board and it uses this connector to connect to the driver board. First, we need to connect this connector. There are two other connectors on the board. One is used to power the driver and it has positive and negative connection point. We'll connect black wire to the negative ground and red wire to the positive. Here we'll simply connect 4 wires for the 4 control signals to the stepper motor driver. The orange will be connected to the first input, yellow to the second, green to the third, and blue to the fourth. On the other end, we'll connect orange to digital pin 2, yellow to digital pin 3, green to digital pin 4, and blue to digital pin 5. For the power, we'll connect the black wire to ground and the red wire to the 5 volts pin. The joystick has both X and Y potentiometers, and switch will use only the X potentiometer, so we'll need to connect the ground, black wire to ground on the module, red wire to 5 volts on the module, and blue wire to VRX, or the value from the X axis on the joystick. The blue wire signal will go to analog pin 0 on the nano. The red wire from the joystick will go to the analog reference power from the nano, and the black wire will be connected to one of the ground pins on the nano. We will start with new project. Select board type. In the component toolbar search box, type stepper. Select the 4-wire stepper motor component and drop it in the design area. Click on this output box with the 4 pins and move the mouse over the digital input pin of digital channel 2. Then click. This will connect all the 4 pins at once. We want to control the speed of the motor with the joystick. For this, we will add pin to the steps per second property by clicking on this pin button here. The joystick will provide analog value between 0 and 1. We want to convert that to steps per second minus 300 to 300. The joystick, when released, does not always stay exactly in the middle, so it is nice to have a little insensitivity dead zone where the joystick value will be assumed to be 0.5 or 0 steps per second. Visuino has special component for this. In the toolbar search box, type zone and select dead zone scaled analog component. Drop it in the design area, connect the output pin of the component to the steps per second property and the input pin to the output pin of analog channel 0. In the object inspector, expand the output range and set the max to 300 and the min to minus 300. Generate the Arduino code and open the Arduino IDE. Compile and upload the code. The code is uploading. I have added a paper clip on top of the stepper motor so we can easily see the rotation. If I move the joystick up and down, the motor will start rotating in the corresponding direction, and I can control the speed all the way to a very low speed, like this one. or a high speed. And there will be slight dead zone in the joystick where the motor doesn't rotate at all. In this project, we'll connect RGB LED to our Arduino Nano. The RGB LED uses 4 wires. One provides power, we'll use orange wire for it. The next one controls the red component of the LED, we'll use red wire. The next one is blue with blue wire and green with green wire. You can see the R, B and G labels on the module and the V label for power. We'll connect the orange wire that provides the power to 5 volts on the Arduino Nano. The red wire is connected to digital pin 3, which has pulse width modulation. The blue wire is connected to digital pin 5, which also has pulse width modulation. And the green wire is connected to digital pin 6, which also has pulse width modulation. We will start with new Visuino project. Select board. In the search box of the toolbar, type sign. Select sign analog generator and add 3 of them to the design area. We'll connect the first one to the analog pin of digital channel 3, the output of the second one to the analog input pin of digital channel 5, and the output of the third one to the analog input pin of digital channel 6. We'll select the second one and set a frequency of 0.3. Select the third one and set a frequency of 0.1. This will make the 3 generators have different frequencies and cycle through all possible values over time. Generate the Arduino code. Compile and upload the sketch. The code is uploading. And now you can see the LED changing its color over time, cycling through all possible color combinations. You can also connect a variety of displays to Arduino. There are many different options, such as 7-segment displays, LED-based displays, LCD displays, TFT, organic LED, and the Arduino can be programmed even to generate composite TV output signal. The displays can be many different types, such as digital parallel protocol, I2C, SPI, or they can use a variety of proprietary protocols. For this project, I will connect organic LED display to the Arduino Nano from the kit. The display is I2C. It needs 4 wires. We'll connect black wire to the ground pin, red wire to the VCC power pin, yellow wire to the SCL clock for the I2C, green wire to the SDA data for the I2C. On Arduino Nano, we will connect the black wire to one of the ground pins, the red wire to 5 volts, the yellow wire to A5, which is the clock for I2C, and the green wire to A4, which also works as data for the I2C. We will start with new Visuino project. Select board type. Add component to control the organic LED display. It is I2C. There are 2 types of components, SPI and I2C. We will select the I2C version and drop it on the form. Click on the Tools button to open the Elements editor and add a Draw Bitmap element. We need to select bitmap to be rendered. Select bitmap and click on the period button. In the editor, click on the Load button. Select bitmap and click to open it. We want the bitmap inverted, so the pixels will be white. You can see the pixels of our bitmap. Click OK. We want the black pixels, the fill color, to be black, and we'll specify the initial position of the bitmap to 30 X and 14 Y. We want to animate the bitmap. In order to do that, we'll need to change the X and Y properties. We'll add pins to them so we can change them. Click on the pin button at front of the property and select integer sync pin. Do the same for Y. Close the Elements editor. Connect the output pin of the display to the input pin of the I2C channel on the Arduino. Add 2 integer sign generators. For the first sign generator, specify amplitude of 30 and offset 30, and some small frequency such as 0.1. For the second generator, set amplitude 14, offset 14, and some other small frequency such as 0.2. We will connect the output pin of the first generator to the X pin of the bitmap and the output pin of the second generator to the Y pin of the bitmap. We also want the bitmap to be rendered every time the generators change. We can simply use one of the generators to clock the rendering of the bitmap. This will tell that every time the generator generates new value, the bitmap needs to be updated and repainted on the screen. The project is ready, and now we can generate the Arduino code and open the Arduino IDE. Compile and upload the code. The code is uploaded. You can see that the bitmap is animated and moving around the display, exactly as we had programmed it. It will follow two sine waves which are out of phase and frequency, and is one type of Lissajous figure. We covered only a very small fraction of what is possible to achieve when programming Arduino boards with Visuino. Here are some additional resources: the main Visuino website, visuino.com, the Visuino wiki documentation, the instructables that I have created, the Hackster.io Visuino community, my YouTube channel, and my blog, where I often post updates and news about the Visuino and the lab packs development. Once again, my name is Bojan Mitov, the president of Mitov Software. Mitov Software offers a wide variety of products, including video processing library, audio processing library, digital signal processing library, computer vision library, data visualization library, visual instrumentation library, artificial intelligence library, Boolean logic library, universal animation library, serial and TCP communication library, universal visual live binding library, a free Delphi library called Mitov Runtime, OpenWire Studio, a graphical development environment for Windows, Visuino, graphical development environment for Arduino. We also support some open source libraries, including the OpenWire library and the iGDI Plus, a Delphi-friendly GDI Plus library. Thank you for attending the IoT Boot Camp and listening to my session.
Okay, so if there's any questions, go ahead and put them in the question panel in the GoToWebinar software. There's been a number of questions as they're going along, and we've been typing answers in here, but Bojan and myself are available now to answer additional questions you might have, as well as review some of the questions that are already in here. So fantastic session, Bojan. Thank you so much.
You're welcome. Thank you.
Let's see. Were there any questions you're going to start with, Bojan, before I start going through some of these?
You mean if I have any questions?
Well, if there was any questions in here that you wanted to maybe address in more detail before I start going through some of these, there's a lot of.
Yeah, I think somebody was asking how easy is to go to production from prototype. Well, generally speaking, Visuino generates production-ready code. So there is a number of people that have already just generated the code and gone to production. Also, with Visuino, it's quite easy to hook multiple boards to work together with I2C communication, and I actually have even posted some tutorials on that. So you can create a whole set of one, as example, master I2C board controlling a number of other Arduinos as slaves, and yeah, you can create quite complex solutions with it.
As I was watching this, I was just like, oh, you could combine this with this, and I'm just thinking of all these different ways we could do lots of different things with this kit and with using Visuino. So there were a few questions about how this relates to Delphi and stuff like that. We probably should have at the beginning explained the agenda is for today one was really introduction to Visuino and Arduino and all the stuff in the kit. So Bojan went through and showed you how to connect different things, control different things, create sketches with Visuino, and download them to the controller to control things. Tomorrow, we're going to start showing how to connect to this from your Delphi app. So you're going to build a Delphi app, and that Delphi app is going to talk to the microcontroller, the Visuino or the Node MCU, and then that's going to then provide input and outputs to two different devices. So then day 3, we're going to start connecting it to a larger infrastructure, and then day 4, we're going to roll that infrastructure out into lots of different other devices, other programming languages, etc. So it's building on it here. Today was really just about showing you all the different pieces of hardware, how to connect to them, how to control them, and I thought it did a great job of that. There's so much great stuff in here, and just to see it do all that do everything there. So now there are a few questions about the different pieces of software that you showed today. So Visuino is built with Delphi, and that is your visual Arduino development IDE, right?
That is correct.
And so when the diagrams there where you're connecting things, that's all Visuino. And then when you hit the button, it generates code and sends it to the Arduino IDE, which comes from Arduino's website there, right?
That is correct.
And then the Arduino IDE actually compiles that code that was generated and sends it off onto the Arduino device or the Node MCU.
That is correct.
Now, would you ever tweak the code in the Arduino IDE, or is it really everything you do is going to be done through Visuino, the Visuino IDE?
In general, everything is done through Visuino. The Arduino IDE is, at that point, is not intended to change the code. It's the same as already generated, let's say, assembly code, which you just upload. It's just an intermediate step in the process of uploading, and allows you, of course, to do a final review and maybe monitor how the compilation and the upload goes, but that's about it. That's the whole purpose of the Arduino IDE under these circumstances.
Yeah. Okay. Okay, let's see. There's some questions here. Let's start going through some of these. What about Raspberry Pi boards?
Right at the moment, I don't have any solution for them. Just I have been out of resources already, covering all of the Arduino boards and all the sensors and stuff. When I get everything more or less in order, then I probably will start looking at Raspberry as well.
Okay, so that's something possibly in the future. Because it uses a different IDE, right? It doesn't use the Visuino IDE?
Yeah, well, the two things are two completely things. The two boards are two completely different things. The Arduino is a microcontroller. The Raspberry Pi is a computer. The Arduino doesn't run operating system. It just directly starts executing code. Raspberry Pi runs on complete Linux. So they're two completely different things to even compare.
Yeah. So I was actually going to mention that there is a blog post, let me see if I can find it here, that talks about how to load Android onto Raspberry Pi 3, and then that once you do that, you can use Delphi to generate an Android app that runs on the Raspberry Pi 3. So let me see if I can find that here. Delphi Android Raspberry. There it is, running Delphi applications on the Raspberry Pi 3. That is an option there. You can do that as well. So we will have a replay available. It'll be posted hopefully later today. That's the objective, just depending on how much we're able to get done. Now, the Visuino is a free download, but it has a trial version that you can use, or you can register it. It's $10 to buy, or $9.99 to buy Visuino. Is that right?
Yeah, the way it works is, first of all, you can always use it completely for free, actually. Every time you run it, it runs for 5 minutes for free, and then you can run it again for another 5 minutes. And I think for many projects, 5 minutes is plenty of time. Actually, you can do a couple of projects during those 5 minutes.
Save automatically at the end of the 5 minutes?
Yeah, it will show you a dialog, and it will allow you to save the work, so you're not going to lose the work you have done within those 5 minutes. And then it will shut down, and then you can start it for another 5 minutes. So yeah, this way you can keep using it for free. There is a trial period which you can get a trial key and run it for 30 days without this 5 minutes restriction. And then you can buy it for $10, and it comes with, it will work forever, the version that you buy, and you can get updated new versions for another 3 months after you buy it. After that, if you want any newer versions, you can buy it again, or you can get for $20 for $19.99. You can get 16 months of free update. Well, basically not free updates, but updates to new versions. and then before the end of these 16 months, if you pay another $10, you get another year of free update, so you can keep it constantly up to date for effectively $10 a year.
Wow. Yeah, actually, I bought during Code Rage when I saw your Visuino session. Then I actually went out and bought my own copy in Communication Lab just because this is so cool. And at $10, it was like a no-brainer for me to buy it. So it's just a great way. And then tomorrow we're going to start showing how to connect with you from Delphi. And it's like, you know what? I always wanted to do Arduino development, but I'm a Pascal guy, Delphi, and I've done a little bit of the C programming in the Visuino or the Arduino IDE, but just to be able to do this rapid application development like I'm so used to in Delphi and have it go to Arduino it was a no-brainer. It's like, okay, I'm just going to buy this and it'll go from there. So very cool, very exciting to see. There's a question here about when uploading to the Arduino, there's no SD card. Does the app disappear, or the sketch, I guess is the terminology they use, once the power is disconnected, or does it remain? How does that work? What's going on here?
Yes, the Arduino actually has a flash. It's very different. That's another difference between Raspberry Pi. Very often you'll see our Raspberry Pi cost, let's say, $5 or something like that. But that's not entirely true, because just if you get the Raspberry Pi, then you have to get another micro SD card where you're going to load the code and so on and so forth. So the price tag immediately starts going up. With Arduino, there is nothing like that. The memory is on the board. It has flash. The code goes into the flash. If you turn it off, the code is already in the flash. And you can even use part of that flash for data. So you can store data, and all of that comes out of the box when you get the Arduino. So yes, it has flash, and yes, you can add external micro SD card module if you want. They sell those modules again for like $1 or something, and you can hook it with, if I remember correctly, their SPI. So you can hook it with the SPI interface and access it.
One thing I discovered with this Arduino is like there's what we showed today is like the tip of the iceberg. There is so much stuff out there, and there's a lot of new terminology and technology that you kind of have to learn, but this makes it all accessible. Hopefully the goal was to give you enough to make it accessible so that you can start making those, adding SD cards and stuff like that. What about power? So if we disconnect right now the USB cable is giving it power. If you disconnect that, it's going to lose power at that point, right?
That is correct.
So is there a way to get a battery pack for it so that it keeps power after the fact?
Absolutely, yeah. The easiest solution that if you're not very experienced with power and stuff like that and just want to play, I personally play with it by using a USB power bank. So the easiest solution is to use USB power bank, and then you can get separated either rechargeable batteries or they were considering to add that into the kit, but I suggested not to do that to keep the price of the kit as low as possible. You can just use a normal battery like 9-volt battery or something and hook into the Arduino and power it with it. There is VIN. I actually showed this pin in one of the videos. I forgot in which particular one. The VIN, I think it's tomorrow. Yeah, tomorrow we'll show that pin. The VIN pin, you can get, I have to look at the exact voltage range, but it is listed in the Arduino boards, something up to like 9 volts you can put on that pin. And the Arduino Nano has its own voltage regulator on the board, so it will convert it automatically to 5 volts and everything is going to work just fine. So yeah, you can power it with off-the-shelf battery.
Yeah, this is it. Kind of, we're moving from the world of software to the world of hardware at this point. Well, combining the two. So if you're new to hardware, yeah, there's going to be some new terminology and stuff for you to learn here. How many? So there's a question about different boards. We're really just showing 2 different types of boards, but there's quite a few other types of Arduino compatible boards out there. Do you want to talk about some of the other boards and what some of the differences between different boards are?
Well, not in this. Yeah, we can talk, but there are probably literally already thousands of such boards. I mean, there are new boards coming literally every single day, and I'm not joking with that. And yeah, many of the boards are almost identical, so they're like already 15, 16 different types of Node MCU type of boards with minor tweaks. Even Arduino Nano, there are quite few versions of it. This is version 3, but there are probably a bunch of sub-versions, and they differ a little bit in terms of USB driver and stuff. So again, there are relatively popular boards, like Arduino Nano is very popular and is one of my favorite boards because it's small, not that easy to burn, it's cheap. Even if you burn it, you don't worry that much about it. You can just toss it, get another one. Node MCU is another one which is among my favorites. Exactly, again, it's small, it's cheap, and it has built-in Wi-Fi, and it has plenty of memory and stuff. The only disadvantage of Node MCU is that it has only one analog pin, and it's not that convenient to use as, let's say, the Arduino pins, but for everything else it's a fantastic board. Then there are big boards like the Mega, which has quite a lot of pins. There are like 50 or so different pins on the board. There are even bigger boards. There are boards with multiple cores in them, boards with GPS, GSM, Wi-Fi capabilities, and what have you. So I probably can spend a whole week going through different boards, and we will not exhaust the topic. So yeah, it's something for everybody to discover. It's what makes it all that exciting, actually. I mean, every day I just see something brand new, and I'm getting excited all over again.
Yeah, I've been following your blog and your Twitter. It seems like every day you're like, hey, I just got this new board and I'm connected it to Visuino and we're controlling, you know, here I'm talking to a GPS or a GSM, or it's like, oh my goodness, it's like everything imaginable is being connected. So yeah, check out some of Boyan's, his blog and his Twitter feed, and you have the, I can't remember what it's called, Instructables page, where you have all these different projects as well. So they're just, it's a huge world of possibilities out there. A lot of the stuff you showed today was pretty straightforward examples, which is great for introduction, but is Visuino something that you could create a lot more complex applications? How complex of an application would you be able to create with Visuino?
You can create extremely complex applications, and I actually did one relatively more complex application during Code Rage, where we were controlling a robot with Bluetooth. So this is one example I have done even with Uno, and again, it's a very low-end board. I have programmed the Uno to run the robot as self-navigating robot, avoiding obstacles. You can create relatively, I mean, quite complex, not only relatively, but quite complex industrial solutions, and I'm sometimes shocked at the complexity of the projects that some people send me with some questions. Okay, how I do this, and then they send me a project which has 50, 60 components in it connected in quite complex way. So yeah, it can get quite complex, and yeah, the Visuino is going to handle it just perfectly fine.
Now, once
I'm sorry, just wanted to mention that as long as you don't exceed the capacity of your specific microcontroller. The Nano's example and the Uno are among the most basic boards, so their memory is quite limited. We're talking about something like 2Ks of memory, right? So it is not that difficult to exceed this type of memory. On the other hand, if you have something like Mega, yeah, you can almost pour anything you want into it. It usually is going to take it. Right?
Okay.
So it just depends how powerful the controller is.
Okay, that was good to know. Once you've loaded the application into the controller, can someone get a hold of that and reverse engineer it back to code again, or is there a way to protect against that, or is that a big threat?
I really don't know. I haven't attempted to do either of those two things. So I'm probably not the right person to say about that. But on another hand, I mean, this is a compiled code. So on one side it's a compiled code, on another side it's a microcontroller. Even if you don't get hold of the code of the microcontroller, you probably can reverse engineer it, I mean the logic of the code, just by measuring what happens on different pins for most parts, unless you're running some really complex filter inside or something. On another hand, even if you extract the assembly code, it will be as complex as reverse engineering assembly code. But if I'm not mistaken, those controllers, they do have the capability to effectively lock the code and prevent reverse engineering it. On another hand, if somebody wants to use expensive equipment and even read the content of the memory using, let's say, X-ray technology, well, then there is very little you can do about that. I mean, yeah, they can crack anything this way. There is nothing which is really absolutely safe. If somebody has X-ray and reads the content of the memory directly from the chip, even without powering it.
Wow, yeah. One thing is that this is a huge community. The Arduino community is a huge community. Actually, the Visuino community is pretty good size too. But if you are concerned about securing your code, go out and take a look in the larger Arduino community, and there you can see probably there are other people having discussions and probably trying to tackle this problem as well. So, and probably having best practice recommendations. So that's something you can look at. And I know from experience, if you do need to some support from Boyan, he'd probably be happy to help you as far as making things more secure if you can help find what that looks like. So great. There's a few comments here, but people saying they've seen kits on like Amazon and eBay and stuff like that. You can buy these Arduino and this hardware everywhere. It is all over the place. Maker Fab ships globally. That's one of the reasons you selected them. If you know what you're looking for, you can certainly buy a lot of the stuff on eBay, which I did a few of those as well. I got a little pile of hardware here I got on eBay for a really good price. We picked Maker Fabs because they made this nice kit. They make good quality hardware. They ship globally. So wherever you want to buy your stuff, you certainly can do that to get going here. Is there any other places you recommend besides Maker Fabs, Boyan?
Yeah, I was surprised. I mean, most of the stuff I get from eBay tends to be relatively on the lower quality end, to say the least, and I have gotten few faulty items. Not many, but I have gotten a few. I was quite surprised by Maker Fabs. I discovered them by accident. I get contacted by a lot of those manufacturers. I personally would recommend them. If you want other high-end, then you should go to Adafruit and SparkFun, which are located here in the States. That I haven't received too many SparkFun things for a variety of reasons, but whatever I have received was very good. From Adafruit, I have gotten quite a few modules, and they were quite good quality. There is another company from which I have gotten one robot, and the robot was pretty decent quality. They also have Arduino kits. I don't have their Arduino kit. I cannot say what's the quality, but if it is similar to the robot, it's probably quite good. That would be Elego. Let me see if I can figure out. ELEGOO.com. So their robot was quite good quality. Again, if their Arduino kit is of the same quality, it's probably quite good. Those are the ones that I can recommend for better quality from my personal experience. At the moment, I cannot think of anything that I have seen which is really good quality. But again, there are so many vendors and so many places you can get stuff from. Yeah,
lots of endless. And like how you pointed out, and this is one thing that took me a while to get over, is because a lot of this stuff is relatively inexpensive. You know, if you buy some, it's like, oh, that didn't really work out. Well, you learned something. You know, if you have something here, you can try that one and blow it up with something. You know, whatever you got to do. With Craig, for example, when he was doing his weather balloon launches, he doesn't always get his hardware back. So, you know, it's important to be able to find cheap hardware in that situation here. This is the the website you're talking about here, Elego, and you were saying you're going to build this, make this robot talk to Delphi app and use your vision library to do.
No. This robot I demonstrated during Code Rage.
Oh, that's okay. That's the other one.
So this one was demonstrated during Code Rage, and I controlled it with mobile phone programmed with Delphi. There is another robot which I have just started to explore, which is from a completely different company and completely different side. That's Kuman. Let me see if I can. Kuman Tech, KUMATNTECH.com. Kuman Tech. So they have this robot which I plan to make work with Delphi and use artificial intelligence and computer vision. It's a much more expensive and much more complex robot, but it's a very interesting robot.
It was KUMA. What was the rest of it?
Yeah, I'll repeat it. KUMANTECH.com.
Ah, all right.
Kuman Tech. Did you get it?
I got it. So let me put that over here.
Yeah, and if you go to robots, yeah, they have robots section. On the left side, if you go to robots, yeah. And then it's that they have few robots, but it is the one which is $311.99. Yeah, on the right. Kind of the right.
Serious robot there.
Yeah, it's quite serious robot. It has a Wi-Fi camera, manipulator, Wi-Fi connectivity. It has Arduino board with all of the control functionality, and theoretically it has, of course, rechargeable battery pack. And theoretically, I should be able to connect to it from Delphi and talk to it, and run some artificial intelligence and stuff like that. But again, I simply haven't had chance to do much more than just assembling it and posting assembling videos for it. The quality is not as good as the Elego robot, but on another hand, this robot is so full of features and reasonably priced for this set of features. From what I have seen, this is the most feature-full robot that is out there within this price range whatsoever. So yeah, well, I can live with having to tweak some things a little bit just because some screw doesn't fit exactly where I want it to go to get such great robot. So yeah, that's another very interesting device for sure.
Very cool. So I just put some links in the chat window there.
Sure.
That some of the links that you just shared, so that people can grab those and follow along. So the session later today is a repeat of this one. What if someone wants to expand on Visuino? Is there a way they can do that? Is that opened up so they can add their own modules to it, or how does that work? Or is that?
Yes. I have created SDK for creating Visuino components. I even posted in the Delphi Pascal magazine. In the Pascal magazine, I posted a while ago article. It's a bit old already, but there is article on creating Visuino components, and all of that will only improve with time. But yes, that you can make Visuino components, and already there are a couple of people that have started writing their own components for it.
That's true. You do have a number of articles in the magazine here. I'll put the link up here for this. If Boyan's a regular contributor to the Blaise Pascal magazine, and so if you're wanting to learn some more about what is he have, your third artificial intelligence article is just in there. So if you're not a subscriber to Blaise Pascal, get the digital. You can get the digital version or the print version. Digital version is a good deal because you can just go online and read it, and I'm pretty sure it includes back issues as well. I can't remember. I've had a subscription for a while now. I can't remember if I have get back issues or not. But anyway, you can. I know you can buy all the back issues as an offer as well. But anyway, check that out. This is a great way to keep up to date on what's going on with Delphi and with some stuff Boyan's doing. So check out the Blaze Pascal magazine. I did put the link in there. Let's see. Arduino modules. Yes, there's an SDK. Let's see. Any prerequisites for tomorrow's session? So there is a blog post I put together. Let's see if I can find it real quick here. That is all the software that you need to have installed for the boot camp. And tomorrow we're going to start using a lot more of it. So if you have, the latest Berlin installed, tomorrow we're going to be doing some with Visuino and with which are your labs? Because I put a link here to the communication lab, instrument lab, and plot lab. Are we going to get all three of those tomorrow, or just the communication lab probably?
Yeah, tomorrow I'll demonstrate the three of them working together. And I also made over the weekend some updates. I made a build last night. Today I will run, it takes 5 to 6 hours to go through the full testing procedure of the build. If everything goes well, in the afternoon I will post the latest version of the libraries, which is exactly what I used during the session. There's some minor tweaks. One of the projects will require the latest version. All the other projects will work perfectly fine with the previous versions.
Okay, very cool. So yeah, there's a link to all the software there. That's the links to the 78279 build of the. And
I will post it on my blog. So the same. I mean, I will update that link that you have posted, and I will make a separated post as well on my blog.
Okay.
So people can get the latest version as soon as it is ready, assuming the testing today goes well, because that's what testing is for. Right?
Exactly what testing is for. Yeah. So here's your blog is labpacks.blogspot.com. You might hear and see all the latest. Yeah. See, look here. He's got the Wi-Fi. What is it? The Wi-Fi camera on the Kumin robot going. So come on, check this out. All the cool stuff you can look forward to doing. Any plans for PIC microcontrollers and MP labs?
PIC is another request. Again, I mean, my resources are so thinly stretched already. I have been looking to add PIC support for quite a while. Again, I mean, if the microchip people one day contact me and help at least financially or something so I can hire some help, I will definitely immediately add support for, hire somebody and start working on PIC support version. If not, it will have to wait until I find some gap into my schedule and try to create a PIC version. And yesterday there was another guy that was contacting me with another type of microcontrollers, asking if I can add support for them. I mean, the same thing. There's so many microcontrollers in this world, and my resources are so limited, and I'm already handling so many product development. So yeah, it's just a matter of resources. That's all.
Yeah, and if the PIC or whatever is something really, really important to you, reach out to Boyan. Maybe you can help him out and get support added, and it'd be beneficial to both of you. You know, you help him with the getting the support added, and you end up with an awesome tool to get stuff done. Let's see. So there was some comments about apparently people had some audio issues. If you did, we'll have the replay posted later today. Hopefully, I'm gonna get that started being edited right after this we finish here, and hopefully get the replay posted. We're gonna try and include the Q&A as well on there. How much larger is the code generated by Visuino versus code that would be just written in the Arduino IDE by itself?
Well, the question is how good of a software developer you are. If you are a really good software developer, I'm sure you can beat the Visuino code. On the other hand, averagely speaking, the Visuino code and the Visuino libraries tend to generate less code than the typically available libraries on the web, and there is a good reason for that. It's not necessarily that the code is so much better written. The Visuino tries to optimize the code. So if some parts of the Visuino libraries are not used, it will attempt not to include them into the generated code. Where most of the libraries that you can get on the web, they are fairly universal libraries. So whatever you do, the whole library typically goes into your code unless you go and manually start modifying the libraries you're using. So on average, you'll get probably better code from Visuino than you can typically write, especially if you use somebody else's libraries, which is what we all do in the Arduino world.
Yeah. Yeah, and yeah, that's a good point. Okay, so there's a few things here. I want to point out that MakerFabs gave us this discounted kit here. This is good for 8 more days. So if you did not order your kit yet, if you're just like, oh my goodness, this is amazing, go out here and order this kit. This is I was pretty impressed with this. This is a good deal from other kits I've looked at. $38. Mine was, I think $50 was shipping, and I got pretty fast shipping. So that's a really good deal for what you're getting in this kit, and it's exactly the stuff we're covering. If you want to, you can scroll on here and just look at the individual pieces of this kit and order those from other providers. We picked MakerFabs because they put together this great kit with a great price, and also because they're good quality piece hardware for good prices. You could find these parts on eBay or wherever, any place else you want to. I'm sure SparkFun or Adafruit's going to have it as well for more money. eBay probably have it for less money. So you can decide. You can probably find it someplace locally as well if you have like a local electronics store, like a Radio Shack if you're in the States. I'm not sure if Radio Shack's outside the States or not. So lots of options on where to get the hardware. But if you do want to get this kit here, which I was quite pleased with the amount of stuff in here for the price. So shop around, pick what you think's best. But this is a good one option. But I still want to point out that it is only good for 8 more days. So good through, Tuesday next week. So let's see. I think we've gotten through most of the questions here. If there's anything else that, Boyan, that you wanted to mention that maybe I missed a question that we wanted to cover, or otherwise I think we're about done.
Yeah, I mean, I think we're probably about done for this session. I want to thank everybody for attending and listening to my presentation. I hope you have enjoyed the content.
Yeah, I really enjoyed it. This is great. You did a lot of great stuff here. Oh, is there a module for consuming a REST API? That's a really good question.
Actually, the answer is that in general, there is a JSON, there are JSON components in Arduino both to construct and parse JSON, and I'm working toward implementing a full REST capability right out of the box. But again, it's going to be probably a month or so before the full REST capability is available as such. For now, you will need to parse it using the component. You simply pretty much will need to hook the socket component into the JSON component, and then it will do the parsing.
Do you have a list on your website of all the boards that Visuino supports?
Not on the website because I constantly add them, but if you run the Visuino, if you just click on the dialog which I showed in the video, it immediately will list the boards.
Yeah, okay. But it sounds like quite a few of them. So yeah, go if you haven't downloaded Visuino yet, go ahead and download it. And you might as well buy it while you're at it. And in my opinion, when something's $10, if you sit through this presentation, you should have bought it already. I mean, it's just one of those things. But Boyan's not paying me to say that either.
Thank you.
The communication lab, I can't remember what the price was on that, but it was also really reasonable. That's what we're going to show some of that tomorrow.
It's $39 actually.
$39, so that's a good price on that as well. So if this is something you're interested in, if you're not on Berlin, get Visuino, get the communications lab, and some of the other labs too. I mean, Boyan's always got the coolest technology, and just go to town. It's so. This is one thing I love about working with Delphi, and I'm going to go off on a tangent here for just a second. Is how amazing the third-party components are. I mean, it's like, oh, I want to build artificial intelligence. Oh, well, just go buy the artificial intelligence lab from Mithoff Software, and oh, boom, look at this. I'm building artificial intelligence with Delphi in no time. So, incredible third-party component vendors like Boyan with Mithoff Software. It's just one of the things that makes Delphi great, and so it's a fantastic opportunity here to, get Berlin, get some of these components from Boyan and just make some amazing Internet of Things technology here. Let's see, Paul just said he just bought this last year, well worth the little investment. Everything is so easy to do. I got a number of people saying they're just ordering it and they're really excited about that. That's great. I am so excited. I think this is a great opportunity, and we're just going to keep building on this week. Tomorrow we're going to start connecting these things to Delphi. We're going to connect them to RAD server. We're going to connect them to other cloud and client infrastructures. We're going to have a JavaScript client, and I mean, just all sorts of stuff going on. So we're really going to just show how to take those little bits of technology that Boyan showed today and just build a huge, complex, well, very robust, let's say robust IoT infrastructure connecting to all these different devices and whatever you want to do. I mean, the sky is the limit here at this point with the amount of flexibility we're showing today. Okay, what is the website for the kit for today's demo? Let's see. I put it here. Boom, there's the kit. All right. Oh, that's the wrong link. What is?
You have it actually right at the moment on the screen, don't you?
Oh, yeah, that is the kit on the screen. So, yep, Maker Fabs. You can find it there. It's, what is it? Kit, product ID 311. And you can get the link to it from the IoT Boot Camp homepage. Lots of options here. Let's see. Email with info about the webinar. You'll get another email tomorrow. Actually, you should probably get another email this afternoon because we're going to have a repeat session this afternoon, and you'll get an email tomorrow as well reminding you about with the links there, and there'll be links in that for the IoT Boot Camp homepage, which is this page here. There's a short URL that points to it. So this page here is going to be the homepage for it, and it has links to the software and then the hardware here. And we're going to expand this with links to the replays for each day as well. So if you get to this page here, bookmark it or whatever, it's the IoT Bootcamp 2007, embt.co/IoT Bootcamp 2007. It will link you out to all the other resources that you need. So fantastic. Thank you to all of you for coming out and joining us. Thank you, Boyan, for this great technology that expands on Berlin to just get people all over the place with Internet of Things.
Well, thank you for organizing the bootcamp.
Yeah. Okay, got two more questions here that look pretty good. There's always going to be more questions. If a board's not directly supported, is there any way for end users to expand by adding custom boards if they know the configuration of it? Or is that something?
In general, the answer is yes, but you will have to contact me and we'll have to work together because at the moment, at least, due to the complexity of the boards and their functionality, adding new boards is not extremely difficult, but does require some knowledge on how to map pins and how to describe the capabilities of each individual pin and so on and so forth. So it is doable, but it will require some additional knowledge.
And what's the power consumption of the board? Probably varies by the board, doesn't it?
It does. It varies quite a lot by board. The ESP, as example, it's one of the interesting things about the ESP8266. The Node MCU is based on it. It can run for quite prolonged period of time on just a very small button type of lithium. I mean, non-rechargeable, but those small batteries. So the consumption is extremely small. Some boards are much more power hungry, of course. So it depends.
Okay, fantastic. All right, if you are signed up today, you are signed up for all the sessions, all the time slots. So if you want to attend the second session tomorrow versus the first session or whatever, you're already signed up, good to go. And we will see you then. This was a lot of fun, and I'm looking forward to tomorrow. Thanks so much, Boyan, and thanks to everybody else for being here.
Thank you. I appreciate everything you did.
Absolutely. All right, bye.
Bye.